Welcome to the Explainer. Today, we're taking a deep dive into an incredibly fascinating project called Laminar. We're looking at a rigorous, completely deterministic software evaluation harness that's genuinely changing how enterprise engineering teams look at AI models. So, if you're tired of just guessing which model to use, or if you're interested in the absolute bleeding edge of AI-driven software development, you're in exactly the right place. Let's get straight into it.
Okay, let's dive right into this. Is a smaller model good enough? Now, you might be thinking, well, it depends. But that question is quite literally a multi-million-dollar problem for enterprise AI platforms right now. See, currently, when teams build AI features, they tend to over-provision. They default to the massive, highly expensive, highly latent models just to be safe. And why do they do that? Simply because they lack a reliable mathematical way to actually prove that a faster, cheaper, smaller model can do the job perfectly well for a specific task. So they guess. And as we all know, guessing in enterprise engineering is incredibly expensive.
Here's our roadmap for today. We'll cover the model selection problem, deterministic evidence-based evaluation, and take a look inside the evaluation pipeline. Then, we'll explore the smallest sufficient model before pivoting to contract-driven multi-agent governance and wrap up with a summary on the evidence-based standard.
Section 1. The Model Selection Problem.
So, right now, model selection is largely what you might call vibes-based. It's irreproducible. You run a prompt a few times, look at the outputs, and subjectively guess which is better. Often teams try to use an LLM as a judge, but let's be honest, those are frequently non-deterministic and incredibly hard to audit. Now contrast that ad hoc guessing with Laminar's approach. Laminar completely replaces those vibes with hard, indisputable evidence. It provides a deterministic, replayable verdict. Basically, if you feed it the exact same inputs, you'll get the byte-for-byte identical output every single time. And that is what allows for justified model tiering instead of blind over-provisioning.
Section 2. Deterministic evidence-based evaluation.
So here's the definitive description. Laminar is essentially an evaluation harness that compares two or more candidate responses to the exact same prompt and explains, completely reproducibly, which one is better. But I really want you to notice the strict engineering discipline at play here. It is absolutely standard library only. There are literally no third-party packages, no hidden network calls, no rogue databases acting up in the background. It is a completely offline, stateless pipeline. This is absolutely crucial because it guarantees that no hidden variables can somehow corrupt your evaluation.
Section 3. Inside the evaluation pipeline.
Now, what's really interesting here is how the engine actually works. The pipeline operates in 5 highly controlled steps. First, it acquires the candidates, so say 2 different models answering the same prompt. Second, it normalizes and strictly validates the schemas. Third, it tokenizes and scores them using a highly stable set-based overlap rubric. Fourth, and this is vital, it detects failure signatures. It specifically looks for turbulence tags, things like hallucination, shallow synthesis, or ignoring context, and assigns a confidence score based on those. Finally, it builds a massive JSON verdict object. It doesn't just rank the models, it mathematically diagnoses exactly where and why a response failed.
The real core intelligence of that scoring step actually lives within this framework, the function by POV lattice. You see, Laminar doesn't just hand out a single generic score. It evaluates what is being checked against who actually cares about it. It uses 4 evaluator functions. You have a judge looking at coverage, a skeptic hunting for noise, an analyst checking precision, and a librarian ensuring completeness. But then, it crosses those functions with specific points of view. Because, let's face it, what a high-level architect cares about is very different from what a hands-on practitioner cares about. This 2-axis grid provides an incredibly nuanced, defensible baseline score.
Section 4. The Smallest Sufficient Model.
And this brilliantly illustrates the ultimate business goal here. Laminar uses an algorithm called the capability split. By running candidates through that POV lattice we just talked about, it can explicitly tell you, hey, for the practitioner lens, this small 8 billion parameter model is perfectly sufficient. But for the architect lens, it fails, so you must escalate to the larger model. It systematically defaults to the smallest model and only escalates up the ladder if it detects failure signatures crossing a specific threshold. So now you have absolute mathematical, auditable proof for exactly when a small, cost-effective model is good enough. So practically speaking, how do developers actually interact with this? Well, it operates essentially like a classic Unix tool. Developers can use a lightning-fast CLI for running evaluation batches. Systems can hook into it via a standard input/output JSON API. But perhaps most powerfully for platform teams, Laminar renders these standalone static HTML reports. These act as incredibly clear visual evidence dashboards. When an engineer needs to justify choosing a smaller model to leadership, they don't have to argue. They simply hand over this undeniable, replayable HTML report.
Section 5. Contract-driven multi-agent governance.
Now, we're going to pivot to something truly mind-bending. This highly disciplined, deterministic evaluation tool was actually authored by a multi-agent AI factory. Yes, you heard that right. Laminar serves as a masterclass, a living worked example of exactly how to govern AI coding agents to produce reliable, standard library software without the whole thing spiraling into chaotic, broken code.
The real secret to this factory isn't some fancy continuous integration setup, it's actually an append-only decision log. In this repository, there's a JSON-L file that acts as the absolute immutable source of truth. Every single decision, every contract drafted, every line of code implemented, and every single audit check is logged right here. It completely replaces messy, ad hoc version control debates with a perfectly auditable history of deterministic decision-making by the AI agents.
The entire process is strictly contract-driven. First, a governance contract is written defining the scope. Second, a grader assigns a difficulty level to determine which model should handle the task. Third, a coding agent implements the code and literally nothing but the code. Fourth, an auditor agent strictly checks for scope drift. If it finds any, it immediately flags the status as blocked. Fifth, an unblocker steps in to resolve the blockage. And finally, a human owner sits at the gate giving directives to either wrap up or start a completely new cycle. An external orchestrator just drives this exact sequence over and over again.
Now, this quote is really at the heart of their success. It's the Laminar anti-scope drift rule. The auditor agent enforces this brutally. The AI is constantly reminded that Laminar produces observations and signals only. It must absolutely never act on its own outputs or try to magically fix the candidate models. This rigid, unforgiving discipline is exactly why an AI factory was able to build such a tightly scoped, perfectly deterministic tool without hallucinating a bunch of useless bloated features.
Section 6. Summary. The evidence-based standard.
So the crucial point here is Laminar's massive impact. As a product, it completely replaces vibes with determinism, giving engineering teams the auditable proof they desperately need to deploy the smallest sufficient model and save massive amounts of compute budget. As a project, it proves that a contract-driven, highly governed AI loop, anchored by an append-only log, can create perfectly auditable standard library software. It really sets a rigorous new gold standard for enterprise AI engineering from top to bottom.
I'm going to leave you with a final thought to consider today. When ad hoc guesswork is completely eliminated from your platform, and you have replayable mathematical proof of what actually works, how much faster and how much leaner will your team deploy the smallest sufficient model? Think about how you can start applying this evidence-based philosophy to your own workflows right now. Thank you so much for joining me on this explainer, and I can't wait to explore the next frontier of engineering with you soon.